In this video, I'm going to demonstrate how to program the red section of my Intelight ESB signal head using Intelight's direct serial cable kit. Intelight has a wireless version and a serial version, or at least they did when they were producing the signal. First thing here, I've got on my Surface tablet, which is conveniently propped up on my 3M visor. You're looking at the active timers pulled wirelessly from the cabinet. So you can see the timers are counting down. What I'm going to do is put them in stop time for this video. You can see the timers are frozen now to keep the Intelight in the red state, make the video a little bit quicker. This is Light Manager. This is the main screen. That Light Manager pulls up when you click on the icon. Obviously you need to make a connection to the signal head. It's just a serial port. I'm using a USB to serial converter. It's through an opto isolator up to the signal head, and you plug into the section that you want to configure in the direct serial cable case. Wireless one, you can access all three heads, all three sections simultaneously, but in this case you actually have to physically plug into the serial port on the controller board. So also looking at the board, there's a couple green LEDs. The solid green LED on the right hand side of the board is a power indicator that comes on when the section is lit, board is active, and there's also a flashing green indicator, which is more or less is an activity indicator. So it's storing ESB data, it's storing light intensity data and diagnostic information for the red section. So when the section is lit and there's activity going through it, that LED blinks green. So that's how that works. So the first thing to do with a direct cable kit is to pull for the section by hitting the green arrow at the top here. And immediately we're talking now with the red section. We've pulled the ID of the board and the description of the board. Obviously it's the red ESB board, firmware version 2.0.1. Switch position refers to the switch on the controller board, which it's hard to see in this video, but is this switch right here. That's in position 2, which correlates to the software to operate the red section. If I switch that out of position 2, the LED may go out, the array may go out because there's no communication between the controller board and the LED array. You can also see here there's now a pulsating red LED on the board, which confirms a valid communication to Light Manager. So that only comes on, the red LED comes on when there's communication between the software and the signal head. So the first thing that we're going to do here is we're going to extract the ESB array by hitting Get, and now it's displaying the current LED configuration on the board. And this is where we do our programming for light steering, programmable visibility. In the vertical direction for lane, if you just use these cursors here in real time, you can adjust for lane. And then there's also horizontal direction. You can adjust for distance away from the head. So as you pull up to the signal, you will the light will come into view. So that's in real time. But the signal only communicates with Light Manager when the light itself is powered up. So for the yellow section, that leaves a very small window to actually do your programming. So what Intelight did was enable a manual set mode, which if we hit the checkbox here, we can make all of our adjustments, and this is for any of the sections, not just the yellow. We can make, let's say we want to program it like that, but the section won't receive any of the data until you hit the set button. So if I hit set button and show the section here, you'll see all the data gets sent at once. So that's how the steering works. So we'll set it back to how I had it. Obviously now we're still in manual mode, so nothing got set until I hit set, and then all the data gets sent at once. So that's kind of Intelight's way of alleviating the short time window for yellows, but red and green can also be programmed this way. So that's how the steering works, the programmable visibility portion of it. On the left side here on the lower half of the screen, there's some status in real time. There's duty cycle and light mode. The duty cycle is obviously the LED duty cycle. Light mode and ambient sensor is information being pulled from the IR sensors on the controller board that control ambient lighting. The signal knows 3 conditions: a daytime, a nighttime, and a direct sunlight. Because I'm in a basement, I had to adjust this pretty significantly because it thought that being in a fairly dark environment that all times of the day were night. So I had to adjust the duty cycle to compensate that. The ambient sensor indicator is just flashing between about 65 and 75 is the state that the ambient sensor is in to confirm a daytime operation. And CPU temperature is in degrees Celsius, but no, it's not 1700 degrees. That's a software bug, and I'm not sure exactly why all 3 sections show between 1700 and 1800 degrees. It's clearly a software bug and not actually running at that temperature. That would be that would melt the polycarbonate housing of the signal. So that ain't correct. But just to show off how it knows light mode and day mode, I'm going to shut off this overhead light in the basement here in this room, and you'll see the signal will now think it's nighttime. So, and again, if you look at the ambient sensor reading, how far it drops from 71 down to about 4. Now for direct sun, I'm going to come over here and grab a flashlight and point it right directly at the ambient sensor at the top signal. And now it says direct sun because I'm pointing it right at the sensor, which is right there at the top where the light beam is. So that's a couple real-time status things there. The next tab over is intensity. This is where you can set all of the IR sensor configuration data here. Obviously we're operating in automatic mode where the sensor's in control. We can also go into a manual mode, and this is more or less a test because it doesn't stay in manual mode. It'll ultimately go back. If there's an IR sensor installed in the signal, it will override it. But we can set the manual duty cycle to 100%, which is full brightness, and hit set. And that's the signal at full brightness. And then we can even bring it down using the, it's not very easy to use with just without a mouse. But let's say we bring it down to 4 and hit set again. And now we're dimming. So that's how manual mode works. We'll go back to automatic mode and set it. Intensity factors and transition points basically tell the signal what's the lower bound and the upper bound to determine what's day and night. So that's how that works. Advanced is there's a couple things here. There's generic messages. This is a factory command. You can send requests and commands to the signal to upgrade it. For software, I don't use anything under generic message. That's a factory thing there, so I don't use that. Alarms. This is where you can pull diagnostic information. There's another sensor in the signal. It's hard to see again. Right underneath the switch, right there almost looks like the IR sensor. Actually, it might be easier to use a flashlight to show this. It almost looks like the IR sensor is just below that switch with a little triangle on it. That monitors the LED itself and watches for any diagnostic issues, or where like the light might be going under spec or anything like that. So we can actually pull diagnostic data by hitting get, and if everything's working as it should. It stores 4 alarms, and you can see there's no issues with that section. So that's how Light Manager works. I apologize for the lengthy video. Hope you enjoyed watching this demo, and thanks for watching.